Hi, in this brief video I'm going to show you how to use a present value table. All these numbers that you see in this huge table are discount factors. Okay, so the first column on the left, as you see, it represents the yield from 0 to basically 0.5, 1, 1.5%, all the way to, as you can see here, 20.5%. Okay, now on the other hand, these numbers across 1 plus r, 1 plus r to the negative second power, etc., they actually correspond to different maturities. Okay, so 1, 2, 3, 4, etc. periods up to here, I think it's 13. Okay, now what if you're looking at, for example, 1.5, and you look at the corresponding number here under 1 plus r and you see 0.9852? Well, what does it mean? It basically represents the discount factor that you should apply to the nominal cash flow when you have a 1.5% yield and the number of periods is only 1. Okay, so let's say it's a 6-month bond and the periodic yield is 1.5. In other words, the annual is 3%. So that would represent the discount factor that you should apply to the nominal cash flow. Now, let's say there's a bond, okay, which has a 4% annual yield. Let's say 4% annual yield, and the coupons are paid semi-annually. And let's say the bond, it has a 4-year term to maturity. So what discount factor should you apply to this bond? Remember, this bond has 4 years term to maturity, but the number of periods should be actually 4 times 2, because you've got semi-annual payments. Okay, so that's why you're actually looking at 1, 2, 3, 4, 5, 6, 7, 8 here. Okay, if you have basically a 4% coupon. But is this right? No, because you also need to divide the annual yield by 2. You should be looking at this. Okay, so it's going to be actually the number that corresponds to this across 8 periods, and that's going to be 0.8535. This is the discount factor that you should apply to the nominal cash flows, where the bond has 4% annual yield and it has semi-annual coupon payments, and it has 4-year term to maturity. Well, now let me show you more specifically here. So here we said the annual yield is 4%, okay? And because the annual yield is 4%, the semi-annual yield will be, the periodic yield will be 4% times 2. In other words, it's going to be 2%, or 0.02. Okay? On the other hand, the term to maturity was 4 years. 4 years. Now, again, there will be how many periods? 4 times 2, 8 periods. In other words, you need to raise the 1 plus r to the 8th power. Okay, so the discount factor is denoted as 1, basically 1 over 1 plus 0.02, which is the periodic yield, to the 8th power. Okay, so if I take out the calculator and calculate, I should have the same number actually. So you might want to check that. Okay, so as I said, it's going to be 0.8535, and that's exactly the number that corresponds to the number here, 0.8535, and that's how you use a present value table.